I'm Shane Taylor.
And I'm Liam Bowe.
And today, we're going to be teaching you about momentum and impulse.
Today we're going to be conducting an experiment where we drop different objects onto different surfaces.
And we're going to look at the data and analyze it to come up with our conclusions.
Now all you need to do is sit back,
relax,
and enjoy
the video.
Have you ever wondered what happens in the split second when an object collides with the ground? How a falling ball's motion transforms into a sudden stop, and why the surface matters so much? Today, we are going to explore critical concepts in physics, and we'll be conducting an experiment on momentum, impulse, and energy transfer during collisions. In this project, we dropped 3 types of balls: a tennis ball, a weighted ball, and a yoga ball, onto 3 different surfaces: concrete, a rubber mat, and wood. Each object was dropped from a consistent height of 1.22 meters, or 4 feet. We recorded their rebound height, contact time, and calculated physical properties using Schwartz physics. Using video analysis and careful timing, we measured the rebound height and contact time of each object as it hit the surface. We ensured consistent drop height and gathered data for each surface and ball combination, totaling 9 trials. By measuring the time of contact and analyzing the forces involved, we uncovered how different materials and drop heights affect these quantities.
Now that Liam explained the basics of our ball dropping experiment, let's look at the physics principles and equations we used to get our results. In order to find the values regarding momentum and impulse, we first needed to find the mass of each object, the drop height, contact time, and the rebound heights of each collision. With a defined mass for each object and consistent drop height of 1.22 meters, we only needed to find the contact time and rebound height. To calculate rebound height, we used frame counts from our slow motion video and measured how long it took the object to rise after the bounce. Using the time until its velocity hit 0, we applied the kinematic formula D equals VIT plus 1/2 AT squared. This gave us an accurate rebound height for each trial, and we also used the same measurement to find the contact time, using our slow motion video to look at the time it was on the surface for. So, now that we had these values, we found the impact velocity, the rebound velocity, momentum change, impulse, average force, and the restitution coefficient, and those equations are all in the back there. Now that we're done with that, let's dive right in.
Here comes the sun, doo-doo-doo-doo. Here comes the sun, and I say, it's alright.
Okay, with our drops, let's first look at the concrete. The tennis ball on the concrete had a rebound velocity of 3.73 meters per second and an impulse of 0.491 newton seconds. The average force during contact was 1.29 newtons with the restitution of 0.76. The weighted ball on the concrete had much more momentum. With a mass of 1.21 kg and a rebound velocity of 3.21 meters per second, it had an impulse of 14.7 newton seconds and a high average force of 44.9 newtons. Okay, that was a lot of physics to take in. Now it's time for a quick physics joke.
I measured impulse with my toaster, and now my breakfast has too much velocity.
Happy birthday to you. Happy birthday to you. Happy birthday, happy birthday, happy birthday to you. To you.
Now that we're refreshed with that nice physics joke, now it's time to look at the rubber mat results. A tennis ball on the rubber mat had a slightly lower impulse on the concrete, with 0.081 Newton seconds, with a restitution of 0.73. The weighted ball on the rubber rebounded a bit more, with 3.3 meters per second and an impulse of 14.85 Newton seconds. Rubber absorbed a bit more of the impact, with a lower force of 44.2 newtons. The yoga ball on the rubber mat rebounded nearly 5 meters per second with a restitution of 1.02. This confirmed that the yoga ball retained more energy than it lost, again likely from internal compression. Okay, that was a lot of physics to take in. Now it's time for a quick little physics joke.
Shane lost all of his momentum. I guess he just couldn't force himself to keep going.
I see your face in crowded rooms, hear your voice in the passing cars. Oh God, everywhere I turn, I'm reminded of you, but you're still so far, so far. I miss you, I miss you, I miss you, I miss.
Now that we're refreshed with another physics joke, now it's time to look at the results on the wood. On the wood, the tennis ball bounced higher than the other surfaces, reaching a velocity of 3.92 meters per second. The impulse was 0.502 Newton seconds, with a restitution of 0.8, the highest of all the tennis ball trials. The weighted ball had an impulse of 15.15 Newton seconds, and a slightly higher rebound velocity of 3.46 meters per second compared to the other surfaces. The yoga ball on the wood had the highest rebound velocity of all of them, at 5.06 meters per second with a restitution of 1.04, the highest of the entire experiment. Okay, that was a lot of physics to take in. Now it's time for a quick physics joke. Why do the momentum create impulse? 7, 10, 11 momentum came first.
Make him in a swimming motion. There you go.
This experiment demonstrated the power of classical mechanics in analyzing real-world collisions. We saw that heavier objects generate more impulse but may not rebound quite as efficiently. We also learned that softer surfaces like rubber reduce average force but also lower energy return. We also discovered that the yoga ball exceeded expected behavior due to the internal air compression with restitution values over 1. Overall, our results confirmed the theoretical predictions between object shape, internal pressure, and surface texture.
That concludes our experiment.
Please like and subscribe for more content like this. This is Shane Taylor and the nonchalant badass Liam Miller signing off. You got it.
They weren't really chasing them. That's